Alright, welcome back to Geology for Idiots. I am your host, Pokemon 2008, and in this episode we will be discussing rocks. Now, before we begin, I would like to recommend a book to those of you who are watching. Now, I'm not going to do this very often, but I just finished this book up a little while ago. It's pretty good. It's called Only a Theory: Evolution and the Battle for America's Soul by Kenneth R. Miller, Dr. Kenneth R. Miller. Book talks pretty much about why it's important to teach evolution to students in, well, every age, from elementary school on up through college. And especially today. And he goes through and refutes most of the basic ideas that the ideas tend to throw out there, like irreducible complexity. Now, for those of you who don't know, Dr. Miller testified at the Dover trial. He was the key witness. So he has a little bit of knowledge on this, if I do say so myself. Also, for those of you who didn't notice, I posted a link to the blog that I started in my profile. I'll also add a link in the description as well. I'll probably be updating that a little bit more often just because it takes some time to make videos and I get lazy and I can write out a rant on that in like 2 seconds. But anyways, it's going to be filled mostly with my rants, and most of them involve stuff posted on Conservapedia. So if you don't want to read my rants, don't worry about it. And I don't care if you go. I just figured I'd point that out because I figured some of you might be interested in that stuff. But I talk about other stuff besides geology. But if you're interested, please go ahead, check it out. After you're done watching the video, of course. I want you to stick through the video. Yeah, and so let's move on. Okay, so in today's video, we're going to be discussing rocks. Yay, rocks. Alright, sorry, I'm a geologist, that kind of stuff happens. Alright, I'll begin by showing you 4 different objects. And I want you to tell me which one is a rock. Now, understandably, I know you guys won't actually tell me, but you get the general idea. Alright, so, is it A? How about B? How about C? And finally, D. Alright, so if you answered D, you're the winner, and you receive, well, yeah, I got nothing for you, but congrats. You know what a rock looks like. I hope that most of you did pretty good at that. So, what exactly is a rock? A rock is defined as a naturally formed aggregate of mineral matter constituting a significant part of the Earth's crust. I don't quite know why they say significant part, because it is the entire Earth's crust. I guess you could get away with saying, the gas where it's spreading, but I mean, even that, it's just magma, which is molten rock. But, moving on. So, I'll break down this definition for you. Naturally forming. Pretty self-explanatory, but again, this is Geology for Idiots, so I guess I should explain. It means it forms in nature, by itself, which means that if we make it in a lab, it is, by definition, not a rock. Alright, so now we all know what natural means. Aggregate. Aggregate generally, or just means a mixture. Mineral. I'm going to define mineral a little bit more in depth in a minute because it's an important thing for you to understand to actually go and understand rocks, okay? So, now a rock has to meet all of this criteria to actually be a rock. So, as we'll see in a minute, when I tell you what a mineral is, this technically makes coal, not a rock. Now, that definition gets a little fuzzy and it's changed back and forth a little bit, but technically, by the definition, coal is not a rock. So, as I said, I'd come back to mineral, and that's because it's going to require a long definition and explanation of its own. With that said, it is important to understanding geology that you understand what a mineral is. So, what is a mineral? Well, a mineral is defined as a naturally occurring solid formed through geological processes that has a characteristic chemical composition, a highly ordered atomic structure, and specific physical properties. They are also inorganic. Okay, so we'll break this definition apart now. Alright, so we'll start with naturally occurring solid. Again, this means it has to be a solid and occurs in nature all by itself without any help for us. This is part of what makes artificial gems worth less than real things. After all, what woman wants a cubic zirconium? None of them. It's made out of the same stuff as diamonds. It goes through intense pressure and heat, and it looks like one, but it's not the same thing. It did not occur in nature. We can make hundreds and hundreds of them, but nobody will want them the way that they'd want a diamond. That applies for all other minerals. Alright? They're formed through a geologic process. It kind of goes back to that whole naturally occurring thing. So we don't have to define this further. But I'll go through it. It means that, geology, the processes that shape the earth and everything, yeah, they form it. And geology is natural. So, got where that one's going? Okay. It has a characteristic chemical composition. This means that when we look at it at the atomic level, it's made up of CaCO3 or SiO2. Okay? So they make it, the mineral is specific. Like when I said SiO2, that's quartz. Quartz always has an SiO2 chemical composition. Alright? Highly ordered atomic structure. This is why, when given the opportunities, minerals will form into their own crystal forms. Like this quartz crystal right here. Notice how it's got the set shape, and when you look for quartz crystals, that's what you look for. That's the way it wants to form. It's not the way it always has the room to form or whatever. But if given the opportunity, like growing into a cave or stuff like that, that's the way it's going to grow. Alright? Specific physical properties. These include, but are not limited to, hardness, streak, color, the list goes on. Alright? And you use these physical properties to separate mineral X from mineral Y. Alright? So, I know quartz's physical properties. I know its hardness, its streak, its color. Alright? But I can also, if I don't know them, look up feldspar's physical properties. And I can then, when I have them both in hand sample or under a thin section, look at their physical properties together and be able to tell the difference between them. Alright? Inorganic. Now, this means it's not the byproduct of a living thing. Example, coal. Alright? So, well, an example would be coal not being from a living, or coal is from a living thing. Okay? So, it's got to be this inorganic thing. Now, again, as I mentioned with rocks, a lot of that's going away. Geologists are looking for a place to stick coal, and so they'll take away that inorganic portion and use it to make coal a rock. But technically you can't do that. Okay? Now, I could do a whole video on minerals, and I probably will. But it's kind of important that you have the basic understanding of minerals prior to continuing to learn about rocks.